All right, let's dive right into this explainer and demystify a topic that is just rapidly transforming the entire AI landscape. Look, if you've ever felt completely overwhelmed by how complex agentic AI workflows can get, trust me, you are not alone. But today, we're going to see exactly how these intricate systems can be totally simplified using standard design patterns. And specifically, we'll look at how LangGraph's new functional API takes basically all the heavy lifting out of the equation. Here is our game plan for today. We're going to decode AI design patterns, see how they build real-world workflows, and then break down Anthropic's 5 core agentic patterns. After that, we'll dive into the LangGraph functional API, and finally, the absolute magic of decorators. Let's get right to it. Section 1. Decoding AI design patterns. Before we actually build anything, we really need to nail down what a pattern actually is. So, what are we talking about here? Essentially, a design pattern is just a standard, totally reusable recipe for solving a common problem. It really doesn't matter what the specific implementation looks like. Think of it like making a stew. You might swap out the veggies or the spices depending on what's in your fridge, but the actual steps, browning, simmering, serving, those stay exactly the same. It's a reusable architectural solution to a problem you face over and over. A great way to visualize this is through architecture. Take the classic Shahi Mosque and compare it to the super modern Faisal Mosque. Visually, they look completely different. One is highly traditional, and the other honestly looks like a modern desert tent. But under the hood, they share the exact same architectural pattern: domes and minarets. That standard structure is there, no matter how the final product gets dressed up. Software design patterns work exactly the same way. All right, Section 2, building real-world workflows. So how do these architectural patterns actually run practical, everyday business processes? Well, imagine you're opening a new bank account. It's not just one magic step, right? It follows a really strict, predefined workflow. First, you've got user input, gathering your ID and forms. Next up are the background checks, so verifying financials and making sure there's no criminal record. And finally, you usually hit a human-in-the-loop step where a real, live person has to manually hit approve. This whole sequence is a workflow, and AI agents need predefined patterns to execute workflows exactly like this one without going off the rails. Moving on to Section 3, Anthropic's 5 agentic patterns. Let's see how one of the biggest research organizations in AI categorizes these architectures. They've defined 5 core agentic patterns. Think of these as the absolute essential tools in your AI toolbox. Depending on the bottleneck or the specific problem you're trying to solve, you're going to pull out one, or maybe a combination, of these to get the job done. Let's break them down one by one. First up is prompt chaining. This one is basically just an assembly line. It's a highly sequential step-by-step process where the output of task A literally becomes the direct input for task B. Say you ask an AI to pull a city name from a document, and then you pass that exact city name to a second AI to generate a fun fact about it. The steps are completely dependent on each other. Next on the list is routing. If you picture a traffic cop standing in an intersection directing cars based on predefined rules, you've got the idea. It's a branching path. The workflow makes a strict decision based on the input. So if it's a security check, route it to Department A. If it's financial, send it to Department B. It only picks one specific path based on those strict if-else conditions. Then we have parallelization, which is an absolute game changer for speed. If you have tasks that don't rely on each other at all, like checking a user's ID, pulling their financial status, and running a criminal background check, there is no reason to do them one by one. Parallelization lets the AI execute all those independent tasks at the exact same time, asynchronously. Once they're all done, it just aggregates the results, drastically speeding up your whole application. Now, it is incredibly common for folks to mix up routing and parallelization because, well, both involve multiple paths, but the distinction is actually super simple. Routing is purely about decision-making. It picks only one specific path out of many. Parallelization, on the other hand, is about execution. It takes all available paths at the exact same time. Basically, use routing for categorizing things and parallelization when you just need raw speed. Pattern number 4 is the orchestrator. The patterns we just talked about, they rely on strict predefined rules. But what if you want the AI to dynamically figure things out on its own? That's where the orchestrator steps in. It acts like a mastermind manager. It looks at your big picture goal, autonomously decides how to delegate tasks to different specialized AI workers on the fly, and then magically synthesizes all their answers into one final result. And finally, we have the evaluator pattern. This is basically your automated quality control loop. Sometimes you just need an AI to grade another AI's homework. One model generates a result, and a second evaluator model reviews it. If it fails the check, it bounces it back for revision. It creates this awesome, iterative feedback loop over and over until the final output completely meets the standard. All right, Section 4, the LangGraph Functional API. Let's get into the practical side of how we actually build these 5 patterns without absolutely losing our minds writing complex code. Historically, building these agentic workflows was a massive headache. You had to manually define every node, explicitly map every single edge connecting them, and rigidly track the state. It was exhausting. But LangGraph's functional API totally changes the game. It gives you a community-tested framework where you can build these complex AI graphs using just simple native Python. You get to focus entirely on the logic, and LangGraph just handles all the messy graph architecture for you. Which brings us to Section 5, the magic of decorators. This is the absolute secret sauce of how LangGraph achieves this simplicity. If you aren't super familiar with decorators, they basically act as wrapper functions. You write a super basic standard Python function, and by adding a single decorator tag above it, you silently wrap your simple code in massive, complex functionality behind the scenes. It drastically reduces manual boilerplate code and makes executing your graph completely seamless. Let's check out the first big one, the @task decorator. By simply typing @task right above your standard Python function, LangGraph instantly knows, hey, this isn't just regular code. It turns it into a distinct, trackable node within your larger AI workflow. Just like that, it automatically handles all the state and tracking for that specific step. But the real heavy hitter, the real power of LangGraph, is unlocked with the @entry point decorator. You place this right above the function that serves as the absolute starting line for your workflow. When you do, LangGraph essentially takes total ownership of your function. It wraps it in the massive core engine required to actually execute, stream, and manage the entire graph. Now, for the deep technical folks tuning in, let's look under the hood real quick. In Python, literally everything is an object. So making an object callable just means you have the ability to execute it using round parentheses, usually by defining an internal dunder call method. So why does that matter for LangGraph? Well, it matters because when you apply that @entry point decorator, LangGraph's wrapper secretly modifies your simple function. It automatically injects a crucial invoke method into your object, making it fully callable and executable. You didn't even write the invoke method. The decorator just handed it to you. And boom, your entire AI design pattern comes to life with zero manual graph mapping required on your end. So there you have it. You've got the full blueprint. You understand the 5 fundamental architectural patterns for structuring AI tasks, and you've seen the absolute magic of how LangGraph decorators abstract away all that coding complexity. The tools are literally right there at your fingertips. So the only question left to ask yourself is, what incredible, complex AI workflow are you going to automate today?